So today we are going to learn what it means to solve trig equations, such as the one that you see up here on the board. Before we start tackling something like that, let's think back. Tell me, what does it mean to solve an equation anyway? If I give you an equation and say solve it, what does that mean your job is? Morgan. And if the variable equals something, and how do I know if it's a solution or it's not a solution? What? Okay, if there's an equal sign, I know it's something that I'm going to try to be able to solve. Maybe if I start getting some examples up here, it'll make my question make a little bit more sense. What does it mean to solve this, I don't know, what is that, a Math 7 kind of question there? Jack, what does it mean to do with that?
To identify what x equals.
Okay, so and in this case, x equals?
Negative 4/5.
Negative 4/5. So negative 4/5 is a solution because if I put that in for x, I get something that's true, right? So we're going to try to find the x that makes it true. Okay, a couple more examples before we jump back to the trig ones. What if I had one barely any harder, but slightly harder? What would it mean to solve this one? What am I talking about now? Billy? Mm-hmm. So what do I get? Oh, positive. So I can't just say x equals 5? Why is it wrong if I just say x equals 5 and say I've solved that equation? Abby? Okay, solving means find everything that makes it true, not just find one thing that makes it true. And might have more answers than that. How many solutions would this last one have? 3. What would they be? Okay, again, those are very easy, but solve means find every single value for the variable that would make the equation true. Now let's start talking about trig equations. Cosine of theta is √3/2. You don't normally have to draw the unit circle. I'm just doing that to help me talk about it here in a minute. Don't give me those panicked looks as you look at that. So this means what angle has a cosine of √3/2? So cosine, what quadrants is cosine positive in? First and fourth. So cosine is going to be positive in the first and fourth quadrants. And you guys show me with your hands, am I here or here or here? Where is cosine going to be? That. Okay, so one place where that is would be right there. How many degrees is that? So I could say a solution is 30 degrees. Is there another place on that unit circle where the cosine is √3/2, Aiden? Okay, so I could say negative 30 degrees. Are those the only two positions on the unit circle where cosine is √3/2? Are those the only two ways to describe those two positions? So Elizabeth, what else could I do, for example? Okay, I could do radians, but even if I stuck with degrees, do I have them all up there? So what's another one? Another way of describing one of those places?
330.
Okay, 330 degrees. What else? What? Negative 30 degrees. How about 390 degrees? How about if I go around twice and then 30 degrees? Or 20 times and then another 30 degrees? Okay, write down all of them. Start writing. Write down, why are you guys giving me these looks? Yeah, it's going to go on forever because I could go around once or twice or a billion times, positive direction, negative direction. It's not possible to write them all down for this particular question. So what the book is going to do, so that we actually can write it down, since we have a finite amount of time to do that in, is to give a restriction. So this one says going once around the unit circle in the positive direction. What are the ways that you could describe those locations? This restriction also, to pick up on what Elizabeth was saying a minute ago, says for this problem we're going to use degrees, not radians. They could have done it 0 is less than or equal to theta is less than 2 pi. And sometimes they will do that, and then you will do your answer in radians. So the only ones of these that we started writing down that are between 0 and 360 degrees would be 30 degrees and 330 degrees, and you do need to put those in order, and you do need to label it with a degree sign. That's what we're talking about when we say solving trig equations. I want to do a couple more with you guys, and then we will move on to getting some other things done today. So this one's a little bit more complicated. I can't just look at it and say, oh, that's where I am on the unit circle. I need to do a little bit of work to get it in terms of sine, cosine, or tangent, since those are the unit circles that we've been focusing on learning. And so what we need to do whenever we have one of these is we are going to isolate some trig function times theta equals. So I want to get cosecant of theta. I can't separate that. I've got to keep that together, but I want to get rid of the stuff that's outside of that box, the root 3 and the 2. So, Abby, what do you think we ought to do first to start isolating that? I want to get rid of that 2, and I want to get rid of that square root of 3 so that I just have cosecant theta equals. How do I do that? Okay, so we're going to subtract the 2 from both sides for our first step, and we have root 3 cosecant theta equals negative 2. Okay, I don't want cosecant theta, so Kinsley, or I don't want root 3 cosecant theta, so Kinsley, what do I do to make it just cosecant theta? I'm going to divide both sides by root 3. So now I know that the cosecant of theta is negative 2 over root 3. Now, have we started learning a cosecant unit circle? You guys want one more unit circle to try to be learning? So let's see if we can switch this to something that we do know how to work with. So, which trig function is cosecant related to? Sine. It is the reciprocal. You have 2 ways that you may show this. We are going to take the reciprocal of both sides. So, you may do it in 1 step or you may do it in 2 steps. If you do it in 2 steps, you first say cosecant is 1 over the sine. So I have not changed it, I've just renamed this one. Would be negative 2 over root 3. And then taking the reciprocal means turn both of those upside down. So if I turn the left upside down, I have sine theta over 1. And if I turn the right upside down, I have negative root 3 over 2. If I do it in 1 step, the reciprocal of the cosecant is sine. The reciprocal of negative 2 over root 3 is negative root 3 over 2. Either way, here's my equation that I'm now solving. Everybody with me to there? Biggest mistake students will make is they will do 1 over the sine is negative root 3 over 2. So you've got to be careful about that. So now we want to know, we're thinking about our sine unit circle. We need it to be negative root 3 over 2. Which quadrants is the sine going to be negative in? Morgan? So the 2 bottom ones, the 3rd and the 4th, so we're looking at these 2. Sine is that y coordinate on the unit circle. So it's negative 1 when I'm down here, negative root 3 over 2, negative root 2 over 2, negative a half. So it's the one that's the closest to that negative y-axis. My restriction on this problem said use degrees one time around the unit circle. So how many degrees am I talking about for these two positions on the unit circle? Holly? So 270 plus or minus 30 degrees would give us 240 degrees and 300 degrees. Questions for that one? Okay, so just a couple more of these since it's kind of new to get some good practice here. Same thing, we need to get secant of theta all by itself. So Sophie S., why don't you tell me the first step I need to do? Okay, as a positive. So if I subtract 3 root 2 from both sides, I have that. L, now what? Divide both sides by 3. And so now I have that the secant is negative root 2. Secant is related to which function? Cosine. So secant and cosine are reciprocals. So if I take the reciprocals of both sides, I have the cosine. So secant is 1 over the cosine. And if I flip that, I have just cosine. If I flip this one, I have negative 1 over root 2. And I haven't learned my unit circle that way, so I'm going to rationalize that denominator. And I need negative root 2 over 2. So where's cosine negative again, Ava? Cosine's the x coordinate, so second and third quadrants. So we're in these two quadrants. And what is the reference angle when it is negative root 2 over 2, Jack? So we're at the 45-degree spots in those two quadrants. So if we are at the 45-degree spots in those two quadrants, how many degrees do I need for each of those? Grace? I'm at the 45 spots in the second and third quadrant. So 135 degrees is one of them. So 180 plus 45 more is going to be 225 degrees. We'll get faster and faster with these, the more of these problems we do. And the more, let's see, maybe I need to start throwing some degree unit circle quizzes at you. Questions, though? Don't have any of those copied right now, but maybe I'll make some copies to get us to work on those. All right, this one's going to be shorter. Ayla, what should I say first? Okay, subtract 1, so tan theta needs to be negative 1. Which quadrants do I have a negative tangent? Second and fourth quadrants. So tangent, opposite over adjacent. So if I draw my reference triangle in there, my opposite and my adjacent have to be the same length as each other. If opposite over adjacent is 1, or negative 1 in this quadrant. So what's my reference angle? 45. So what's my degree for the second quadrant? And for the fourth quadrant? How much? Any questions with that? Okay, then that wraps up the note-taking for today.